Hello students, all students are welcome to my chemistry class. Today we will discuss what is a nucleophilic substitution reaction. Okay. So in short, we call nucleophilic substitution reaction as SL reaction. That means, in generally, in case of substitution reaction of alkyl halides, the carbon halogen bond is polar. This one is carbon halogen bond, and this may be hydrogen or alkyl. This bond is polar because we know halogen is more electronegative than carbon. So, in this bond, the electron drifted towards the halogen atom. So, it gets some negative charge and it gets some positive charge. So, nucleophile. This nucleophile means nucleus loving species. That means the species actually contains one or more lone electron pairs or negative charge. So it can be negative or neutral species. If it is neutral species, it should contain at least one lone electron pair. If it is a negative charge, in that case also it contains at least one lone electron pair. So, if it attacks this carbon atom, why? Because this carbon atom is electron deficient center. That means it is nucleophilic center. It is called nucleophilic center. So nucleophile attacks the electron deficient carbon atom and the halogen atom will leave the system. It has to go from the system. This substitution is called nucleophilic substitution. It may be happen in two types. That means SN reaction is divided into two types of reaction. One is substitution nucleophilic unimolecular, that is SN1, and another is substitution nucleophilic bimolecular, that is SN2. This is substitution nucleophilic unimolecular. Actually, it is unimolar, but it is a misterminology as unimolecular. And this is substitution nucleophilic bimolecular. It is also second order reaction, but it is a misterminology as substitution nucleophilic bimolecular. That means nucleophilic substitution reaction can be happened in two different ways. One is substitution nucleophilic unimolecular and another is substitution nucleophilic bimolecular. We are now describing the SN1 reaction and SN2 reaction separately. So here is the list. When an alkyl halide reacts with a electrophile, if the reagent, this is the reagent, this is the nucleophiles from the reagent, and the substitution product, and these are the class of main products. Okay. So when reagent is NaOH, the nucleophile will be OH minus, and the substitution product will be alcohol. And when reagent is H2, one of the low electron pair of oxygen atom of water molecule can act as a nucleophile, joining the lone electron pair to the nucleophilic center. So H2 is nucleophile here, and the substitution product is similarly alcohol. In the case of sodium alkoxide, nucleophile is alkoxide ion, and it acts as nucleophile, and the product is ether. When reagent is sodium iodide, iodide ion acts as nucleophile, and the product is alkyl iodide. Similarly, in the case of ammonia and primary amine, it may be secondary amine. In the case of ammonia as a nucleophile, the product will be primary amine. In the case of primary amine as a nucleophile, the product will be secondary amine. If it is secondary amine, the product will be tertiary. When the reagent is potassium cyanide, cyanide ion, the negative charge remains on carbon atom, act as nucleophile and produces alkyl cyanide, whereas when silver cyanide is used, the reagent is silver cyanide, then nucleophile will be isocyanide, because cyanide ion is an ambient nucleophile. Generally, potassium cyanide in aqueous solution, it is an ionic compound. Okay. So the electron pair on carbon atom is more polarizable. So it acts as a nucleophile, and alkyl cyanide is the major product. But when silver cyanide is used, silver cyanide is basically covalent. So this bond is not broken. In this case, the low electron pair of nitrogen atom donates the nucleophilic center, and attack occurs through the nitrogen end. There is a product is alkyl isocyanide. Now we will discuss nucleophilic substitution reaction in two different ways. That means the nucleophilic unimolecular and substitution nucleophilic bimolecular. Okay. That means SN reaction is divided into substitution nucleophilic unimolecular and substitution nucleophilic bimolecular. SN1 and SN2. So we are about to discuss differently SN1 reaction and SN2 reaction. When an alkyl halide dissolves into carbocation and halide ion, that means if the carbocation is stable, that will happen. So in case of tertiary alkyl halide, suppose this is the tertiary alkyl halide. Here is tertiary alkyl halide. So it will be dissociated a carbocation which is definitely stable type and this is profile. So this is very, very stable because this is a 3-degree carbocation. So in this case, this carbonate atom is acidity hybridized, but when X minus leaves the system, it will convert to a sp2 carbon. You know, in sp2 carbon, there is a carbon cation and it's a vacant p orbital. If we suppose this is the plane of the carbon cation, then one of the lobe of p orbital will be given on this plane and on this plane. That means perpendicular to the plane of the carbon cation. Okay. So nucleophile in this case can attack from this side or maybe from this side. So you get two products. One is this one product and another product will be every nucleophile attacks from this side to be the product. If it attacks to this side, the another product, nucleophile will be even shared and this will be valuable, this will be propyl group and this will be ethyl group. So this is the enantiomer pair. Both are mirror image to each other. So this possibility is 50% and this possibility is 50%. So actually we will get a racemic mix. This is a racemic mix because it will be produced 50% and it will be produced 50%. So for acid-bond reaction, if the halogen attached to that carbon atom, which is substituted by three different alkyl groups, it may be three different alkyl groups or it may be one hydrogen and two different alkyl groups. In that case, acid-bond reaction, through acid-bond reaction, the product will be a racemic mixture because the nucleophile can attack from above the plane as well as below the plane to the nucleophilic carbon center equally. That means 50% and 50%. So we get the racemic mixture. Now I will discuss the SN2 reaction, that means substitution nucleophilic bimolecular reaction. Substitution nucleophilic bimolecular reaction. In case of SN2 reaction, the substrate is an alkyl halide. I am taking a alkyl halide in which the four substituents are different. This is halogen, this is alkyl, this is hydrogen, and this is deuterium. So nucleophile attacks from back side, and this bond will be broken. This is the nucleophilic center. This is sp3 hybridized. So after attack of nucleophile, you see this is a transition state we appeared. This transition state are like this. Hydrogen and this is deuterium. So this is sp2 hybrid and the bond between nucleophile and carbon, nucleophilic center carbon is half formed here, and bond between carbon and halogen, this is the leading group. This is the leading group. This bond is breaking and this one is forming. This is the halfway in transition state. After that, the carbon nucleophile bond will be formed, and you see the stereochemistry of the substrate and the product is completely opposite. The stereochemistry is completely reversed. So, in that case, this is also a sp3 carbon. You see here halogen atom in right side, in that case nucleophile is in left side, and the stereochemistry is completely reversed. So in case of SN2 substitution, the stereochemistry will be completely opposite compared to reactant. So this is all about nucleophilic substitution reaction, that is SN1 and SN2. You are always welcome to my chemistry class. Thank you all.